rather utter astonishment, they discovered that irrespective of the speed of rotation given to the lodestone always stopped in a particular direction. They could not understand why it was stopping always in a particular direction. Like suppose if you rotate it very quickly, it would rotate, and by the time that rotatory energy is lost, it would rest at a particular direction. If you rotate it with some lesser speed, it would again regain its position. Or the larger question here is that why does the earth behave like a bar magnet, or why is the earth a bar magnet? Why the earth behaves like a bar magnet? The earth's magnetic properties, because when we were doing the evidences related to the continental drift theory, do you remember I told you that there is a geological similarity between the Appalachian Mountains and the mountains of Western Europe, and the geological similarity also indicated similarity in terms of magnetic properties. So that in that class I told you that in the future classes we will understand in greater depth what do we mean by this term magnetic properties of the rocks. In fact, there is a famous term which is used for it, which is paleomagnetism. The rocks are the fossils to understand the magnetic properties of the past. In fact, the rocks are the reservoirs through which we understand how the Earth's magnetic field has changed or is changing throughout the geological time. Do you understand that? So we will start the class with the basic understanding of the term geomagnetism. So let's have a look at what do we mean by this term geomagnetism. In very simple words, if we break down this word, we will understand geomagnetism simply means the magnetism of geoid. And you know, geoid means earth-like or earth. It means geomagnetism simply refers to the magnetic properties of the earth. The earth itself is a huge magnet which controls the orientation of all the other smaller ones which are placed over its surface. In order to develop our understanding to that level, we must go back in time, and we must go back to the time of the ancient Greeks. You know that the Greek civilization was a prosperous civilization in the ancient times. So the ancient Greeks, like Eratosthenes was also a Greek scholar, the polymath who coined the word geography. So the ancient Greeks, they were aware of the mineral called magnetite. In fact, magnetite is an ore of iron, like you have other ores like hematite, magnetite, etc. Clear? So magnetite is an ore of iron. The Greeks used to call magnetite as lodestone. We call it magnetite today because of the progress that chemistry has made, but at that time the Greeks used to call it lodestone, and they were aware that this lodestone, suppose this is the lodestone, it had attracting properties. It means it can attract iron rich materials and keep them with it. It means it has some sort of magnetic properties. That is what the Greeks knew. The Greeks could not understand what is the reason behind this magnetic property of lodestone. Today we know that it's an ore of iron, so it has iron rich matter which is magnetically susceptible, and that's why this attraction which relates to the lodestone. Almost 1,000 years later than that of the ancient Greeks, or even a little bit more than that, the Chinese, what they did was they freely floated lodestone, pivoted it to a central axle and fixed it to a wooden plank, and found out that the lodestone always stopped in a particular direction. What do I mean by this? See, this is what they did. Suppose they took a lodestone, and a lodestone, like a magnet, has a north end. So suppose this is the magnetized end or the magnetic north end of the lodestone. So they took a small flake of the lodestone or a small bar of the lodestone, pivoted it to a central axle, it means fixed it to its center of gravity, and then attached it to a wooden plank. The wooden plank just acted as a base in this case. So this is the wooden plank. This is the axle, and this is the load stone. Clear? Now, this is what the Chinese did. They freely floated or rotated the lodestone. It means they rotated the lodestone fixed over the central axle. And to their dismay, or rather utter astonishment, they discovered that irrespective of the speed of rotation given to the lodestone always stopped in a particular direction. They could not understand why it was stopping always in a particular direction. Like suppose if you rotate it very quickly, it would rotate, and by the time that rotatory energy is lost, it would rest at a particular direction. If you rotate it with some lesser speed, it would again regain its position. It means the lodestone and the magnetized end of the lodestone always pointed towards a particular direction. The Chinese, on further inquiry, found out that this direction to which the lodestone always stopped, the magnetized end of the lodestone always stopped, is actually very near to the geographic north, or it indicates the northerly direction. And you see that if you get one direction, you can find out the other direction. If this is north, this becomes the south, this is the east, and that is west. Do you understand that? From your perspective, this would be north, that's east, this is west, and that would be south. So if you get one direction, will you be able to find other directions? Well, definitely yes. During the daytime, finding directions is very easy, because you just have to see the time of the day and where the sun is. If you see that it's evening and here is the sun, and you can understand that is west, so you can understand other direction. So throughout the day, based upon the altitude of the sun relative to the time of the day, you can identify the direction, and with that direction's help, other directions. If it is night time, how can you find directions when there is no sun? Obviously, you can look at the pole star, which is in the northerly direction, and if you get that star, you can find other direction. But if it is a clouded day and you cannot see any stars, and suppose you are in the middle of the ocean, so you do not have any frame of reference also, so no mountains, nothing, so you do not know in which direction you are going. Isn't that very scary to think of? And that was actually the reason in the olden days, and that's why long voyages were not possible. Do you understand that? But when the Chinese rotated the lodestone, pivoted to the central axle and attached to a wooden plank, and found out that irrespective of the speed of rotation, it always stopped in a particular direction, and that direction being the geographical north, they utilized this to make the magnetic compass. You know, the magnetic compass has 4 standard directions: the north, the south, the east, and the west, and the magnetic needle always stops like this towards the north. So with the help of magnetic compass and with the knowledge of buoyancy, long voyages were possible. And from China, this technology transferred to Europe, who put it to good use. Why? Because during those days there was the ancient Silk Route and the medieval age Silk Route, which was a flourishing route of trade, and there was a lot of trade between the east and the west. West at that time was only Europe, because the American continent was habitated, but it was not known, at least to the people of the old world. Do you understand that? So the Europeans, especially the Spaniards and the Portuguese, they adopted this technology and utilized it along with the principle of buoyancy, and with the discovery of gunpowder, they made armed ships and long voyages were possible. In fact, colonization, it would be a good statement to make that the magnetic compass has a great role in advancing the cause of colonization, which was a good thing for those countries of Europe, but it was a bad thing for countries like us because that converted our country into a dependency. Do you understand that? So anyhow, but the Chinese could not understand that why is the lodestone or the magnetic needle is always stopping in a particular direction. It was further later, there was a British geophysicist. A British geophysicist. A geophysicist is a person who studies the physics of the earth, especially the internal mechanism of the earth. His name was William Gilbert. This man made us understand that why the magnetic needle is always stopping in a particular direction. And this is what he said. He said that this happens because the earth itself is a huge bar magnet which controls the orientation of all the other smaller ones. I'm repeating myself one more time. He said that the magnetized end of the magnetic needle or the lodestone always stops in a particular direction because the earth itself is a huge bar magnet which controls the orientation of all the other smaller ones which are present over its surface. If you're not understanding what this statement actually signifies, you can imagine this example. Think of this. Suppose I have a huge paper, a hard white paper like over which you draw some pictures and all. So think of those hard white sheets, and that paper is flat, rectangular in shape, and it is floating in mid-air. Now, it is very difficult to imagine that how the paper would float, but just for the sake of imagination, imagine that the paper is levitating in mid-air and it is floating like that. Do you understand that? Now, what do I have is, I have a small jar. In that jar, I have minute bar magnets. It means I have small bar magnets, and you know small bar magnets would have north and south end. So I have a lot of them in a bar, in a jar. Do you understand that? Or something like that. So what I do is, suppose this is how the paper is floating. And from this jar, this is what I do. I take huge number of or few pieces of the small minute bar magnets and I throw them randomly over the paper so that they rest over the paper, and then I just spread them using my hands. Do you understand that? Now, tell me, will it be fine to assume at this point that these small bar magnets which I have taken from the jar and thrown over this floating paper, they would be placed over the floating paper in a haphazard or random fashion? Will it be safe to assume at this point? Well, very rare. Yes, you can say that, so you can understand that they would be arranged something like this in any fashion. It means maybe this is north, this is south, this is north, this is south, north, south, north, south, north, south, north, south. It means they would be arranged in any random fashion. And what would be the pattern? It is anybody's guess. Kuch bhi ho sakta hai. Do you understand that? Now this is what I am doing. I hope you are with me till this moment, that the paper is floating and small pieces of bar magnet are spread over it and they are arranged in a random fashion. Now this is what I do. I take a huge bar magnet which is almost the size of this paper which is floating, and I place that huge bar magnet under the paper. What would happen to the small magnets which are placed over the paper? They would immediately realign themselves as per the orientation of that huge bar magnet. Do you understand this? It means, suppose if under this I bring a huge bar magnet and it has a magnetized north and south end. Immediately all the small pieces of magnets that are spread over the paper, they would realign themselves as per the orientation of this huge bar. This is what Gilbert is saying. Gilbert is saying that the earth itself is a huge bar magnet. So if you rotate a lodestone, or if you have a look at the magnetic compass, the needle of the magnetic compass, it is just following the orientation of the huge bar magnet which is located in the interior of the earth. So what Gilbert is saying, that the earth itself is a huge bar magnet which controls the orientation of all the other smaller ones, and that is the reason why the magnetized end of the magnetic needle or the rotating lodestone always stops in a particular direction. You can do this experiment. You can tie a thread to the center of gravity to a small bar magnet with a particular north and south end, and you can rotate it or you can freely float it, and you will see that irrespective of the speed of rotation, it would always stop in a particular direction. In fact, this small bar magnet would be following the magnetic orientation of the largest bar magnet, which is the earth itself. Now, the next question that arises at this point is, chalo ye humne samajh liya that the earth is a huge bar magnet which is controlling the orientation of all the other smaller ones, and that is why the magnetic needle or the lodestone is stopping in that very particular direction all the time, irrespective of the speed of rotation. Ye to samajh mein aa gaya. But the question, or the larger question here, is that why does the earth behave like a bar magnet, or why is the earth a bar magnet? Why the earth behaves like a bar magnet? Well, to understand that, Gilbert says we must look into the internal structure of the earth. Now, one classification of the internal structure of the earth is that it is made out of 3 layers of differing densities called Sial, Sima and Nephi. The other way of understanding the earth's structure is it is divided into layers of crust, mantle and core. The core has 2 parts, the outer core and the inner core, and both the outer core and the inner core are made out of nickel and iron. It means they are Nephi layers. But the point is, the outer core is in a liquid state, whereas the inner core is in hard solid state. So this is what I'm highlighting. Suppose this is the inner core, which is solid, and then there is the outer core, which is liquid. And you know that liquid means there must be iron and nickel present in the outer core, which must be present in a molten state. Very much similar to how iron, after being melted, comes out in the form of slurry that flows through a steel plant. वैसे ही लग रहा होगा यहाँ पर. And why the iron and nickel elements have melted at the outer core? Because it is believed at the outer core there is a preponderance or dominance of radioactive minerals. These radioactive minerals, when they disintegrate, they release radiations, and these radiations generate heat energy. Do you understand that? And this heat energy is responsible for the melting of nickel and iron. That's one thing that you must keep in mind. Secondly, as we increase the depth, we know the superincumbent load of rocks or the overlying load of rocks increases. Hence, there is increase in pressure. Increase in pressure causes an increase in temperature, and that increase in temperature is perhaps responsible for the melting of the outer core. Then the question must be, why the inner core, which must be experiencing a greater pressure than the outer core, does not melt? Well, some geologists believe that if you apply more pressure, maybe the melting is not possible. Why? Because you see that when there is pressure, there is heat, and heat causes melting, and when things melt, obviously the molecules move away from each other. But think of this, if suppose I have some sand in my hand, and I put my other hand and I apply pressure on that sand, you can understand that soon I can make balls of sand. It means that the molecules have come closer to each other due to application of pressure. And if molecules come closer to each other, then you can understand that it would be like if in a gas the molecules are farthest rather, in a liquid they are farther, but in a solid they are the closest. So that's why extra pressure is not allowing the molecules to go away despite the heat which is produced by the pressure. That's why the inner core is in a solid state. Maybe that is one explanation, because I told you our knowledge about the interior of the earth is very meager, and we must not claim that this is perhaps the reason. The other reason, which can be a possible reason why the inner core is solid, is maybe in the outer core there is a presence of or a predominance of radioactive minerals which are disintegrating and releasing a lot of radiation, which is adding up to the heat. In fact, in 2014 there was a research which was done with respect to the outer core, and it was found out that near the outer core, or at the boundary of the mantle and the outer core, there is a small layer called the D layer. That D layer is very much similar to the asthenosphere. It means the layer which lies below the lithosphere and which is the source of all the magma that pours out during the volcanic eruptions. So that D layer is very much similar to that asthenosphere which lies at a much higher, you can say much closer to the surface. You can say something like that. So that D layer has a lot of concentration of radioactive minerals. So बहुत simple words में हम ये बोल सकते हैं that near the outer core maybe there is more radioactive minerals. That's why the outer core has the metals here have melted, nickel and iron. And secondly, the pressure is not so much that it does not allow the molecules to go away when they melt due to high temperature, which itself is caused by pressure. I hope you have understood this, right? Now, we know that the earth is slightly tilted on its axis. Suppose this is the geographical North Pole and this is the geographical South Pole, and the earth rotates on its axis from west to east. हमें ये पता है, clear? Now, if the earth rotates and inside the earth there is a layer which is made out of liquid. The outer core is liquid. Keep this in mind that the inner core, it is solid, while the outer core is liquid. Clear? So when the earth rotates on its own axis, the outer core materials also spin within the outer core layer. ये वैसा ही है जैसे बचपन में आपके साथ हुआ होगा, like suppose you are going to a playground और आपने बहुत सारा खेल लिया है शाम को और अचानक आकर आपने बहुत सारा पानी पिया, and then you went back to the playground और आप फिर जब दौड़ लगाने गए तो आपके पेट में पानी उछलने लगा. This is almost similar like that. So अर्थ के पेट में भी आप ये समझ सकते हो कि पानी है, but पानी नहीं है वो, it is melted nickel and iron present in the outer core. So when the earth rotates on its axis, this outer core materials, they also keep on rotating or spinning. Do you understand that? And the outer core is made out of what kind of materials? Nickel and iron. And you know that as they are rotating, they must be crashing against each other, or they must be colliding against each other. And if two objects they collide, do you understand, there is generation of friction, and due to friction there is generation of heat. Whenever there is collision there would be friction, and friction will always generate heat, and heat generates charge.